students, in our previous video we have derived the potential due to point charge, due to system of charges, due to dipole. Today we will discuss or derive the expression for the potential energy of system of charges. So what is potential energy, which we have already discussed in our previous video? That is always stored in the form of work done which we have applied to bring any charge from infinite to any certain point. Suppose we are bringing this charge from infinite to this certain point. We have applied work done, and the work done is stored in the form of potential energy in this charge before movement, and we expressed in by U, that is potential energy, and it is applied work done, that is W, and the expression for this in the form of potential, that is Q into V. Is that clear? Okay, now we have any point in certain region and we are bringing any charge Q1 from infinite to this point. So is there any work done will applied here? No. Why? Because here in this region you are seeing there is no charge is placed in this region. So any charge is not in this region, which means we can smoothly bring this Q1 from this infinite to this point. No charge will make any effect in this charge. So we can smoothly bringing it. That's why the work done is, we are not putting any effort, so work done will be 0 in this case. Now there is any 2 points. One is Q1 and this is Q2. Q2 charge is placed here, which we have bring from infinite to this point, and the distance between the charges is R12. This is for two charges. Two charges are placed in the region. So how we will find the potential energy? We simply apply that's U equal to W in the form of work, that is Q because of Q1 into V, and now we simply put the potential formula, potential expression because of this Q2, and that will be Q1 into 1 by 4 pi epsilon naught Q2 upon the distance is R12. So expression will be Q1 Q2 upon 4 pi epsilon naught R12. This is for the two charges. Suppose in any region there are three system of charges are placed. This is Q1, this is Q2, and this is Q3. Now because of these 2 points, the distance we are taking R12, here we are taking R13, and here we are taking R23. Okay, now we will find the expression for the potential energy, that will be always in the form of work done. So because of, in this point, because of these two charges, the expression will be Q1 into Q2 upon 4 pi epsilon naught R12, because distance is R12. Now because of this, that will be Q1 Q3 upon 4 pi epsilon naught R13. Distance is R13. Again, because of these 2 points, Q2 Q3, Q2 into Q3 upon 4 pi epsilon naught R23. The distance is R23. So this is the potential energy because of system of charges, where how many charges are placed here? 3 charges. Okay, now we will see the expression for the potential energy due to 4 system of charges. I am rubbing this. I hope you noted down this. Please take a screenshot. And the potential energy I have already expressed in previous video, so you can go through with that. That will be more clear. Okay, now we have, this is for 3 charges. Now we have 4 charges. Okay, so that is Q1, Q2, Q3 and Q4. Now we will join it simply like this. Okay, right? These are the points where the charges are placed. Now we simply find the expression for the potential energy, that is U. Because of this Q1, which charges are making effort? It is also a charge. So from this to this we are marking R12, from this to this we are marking R14, and 1 to 3, that is R13. Okay, from here to here we are marking R23, from here to here. This will also make effect, and this will we are marking R24, and from this to this point, that is R34. You get this? Now we will find the expression because of this, that will be Q1 into Q2 upon 4 pi epsilon naught. The distance is R12 plus Q1 Q4, or we can take Q1 Q3 upon 4 pi epsilon naught R13. The distance is R13. Now Q1 Q4 upon 4 pi epsilon naught R14. Okay, in this point we have taken. Now in this point, that is Q2 plus Q2, because of Q2 Q3 upon 4 pi epsilon naught. I'm rubbing this. 4 pi epsilon naught. The distance is R23, right? Now in these 2 points, that is Q2 Q4 upon 4 pi epsilon naught R24, and one more, that is Q3 Q4, that is Q3 into Q4 upon 4 pi epsilon naught R34. Okay, we have marked all the potential energy in every point. Now we can write it. U equal to 1 by 4 pi epsilon naught is common. We can take it common. In every term you are seeing. So we simply take it outside the bracket. And in the bracket what we will get? That is Q1 Q2 upon R12 plus Q1 Q3 upon R13 plus Q1 Q4 upon R14 plus Q2 Q3 upon R23 plus Q2 Q4 upon R24 plus Q3 Q4 upon R34. Okay, you get this? We can write it like this. Now you are seeing the pattern here. Q1 Q2 in the position vector, that is R12, Q1 Q3, the position vector is R13. You are seeing the pattern here, 1 2, here 1 2, 1 3, 1 3, 1 4, 1 4, 2 3, 2 3. So in combined way we can write it potential energy 1 by 4 pi epsilon naught. We can take sigma for all, and we can write it in the form of J and K. So here Q J Q K upon R J K. If we will put here 1 in the place of J and 2 in the place of K, then we will get R12 here also, And again, if we are taking 1, 3, in the place of J we are taking 1, in the place of K we are taking 3, then it will be R13. So in the combined formula, this is the expression in combined way for the potential energy of the system of charges. Okay, and we have seen for one charge, the net energy will be 0 because work done is 0. For 2 charges we have seen expression, for 3 charges, for 4 charges. So you can find it for the 5 system of charges, 6 system of charges. Okay, so this is the basic formula for potential energy of system of charges. Okay, just take a screen. Now potential energy in an external electric field. Okay, first we will find it for the single charge. Okay, now we know the potential energy is when we bring any charge from infinite to any certain point, the work done which we have applied, that is stored in the form of potential energy. So here any point A and this is any point B which is in placed infinite position, and any charge Q we are bringing from this infinite to this point A, we will do some work done and which is stored in the form of potential energy. So the expression is U equal to, and this is the field, electric field, that is external electric field. Okay, here the point is placed where we are bringing the charge from infinite to this point. So the combined potential energy will be because of Q into the potential at final position minus initial position. So in point A the potential will be VA. At this point the potential is VB. So this will be Q into VA. At infinite we know the potential is 0. So we simply put here 0. So combine the potential energy will be become Q into VA. So this is the potential energy in external electric field because of single charge. Okay, we have just bring this single charge from infinite to this certain point. This point is placed in external electric field. Okay, now we will see the potential. Just note it down or take a screenshot. Now we will find the potential due to two system of charges. Okay, now 2 points A and B both are placed in electric field. This is electric field, and this is the charge Q1, Q2 which are in infinite position. Now we will bring this charge. Suppose we are bringing this Q1 in this position, and these 2 points are placed with some distance that we are marking R simply. So bringing this Q1 from this point to this point, the potential will be in the form of work done, that is W, because of Q1, that is Q1, potential at this point, that is VA, minus in this infinite the potential is 0, so that will be Q1 VA. Okay, that is the potential in, we are just marking it U1. Okay, now we just bring the charge in this position. So some potential will be applied because of this point B. So what will be the potential because of this point? That will be VB, the potential of VB, plus now this is the point which is also applied the potential here, that will be 1 by 4 pi epsilon naught Q1 because of Q1 charge upon that will be distances R. So this is the combined potential in this position B because of A. Now we will find the potential of work done, potential energy in this point that we are marking U2. That again the work done, that will be Q2. Now we are bringing this Q2 charge here and we will do some work done here. That will be VB, potential at this point minus potential at infinite, that is 0. So that will be Q2 VB. Now we will see here and we will put the combined potential at point B, that is VB plus 1 by 4 pi epsilon naught Q1R. So we simply put this potential, that is Q2 VB plus 1 by 4 pi epsilon naught Q1 upon R. Okay, now we have potential at this point, we have potential at this point. So combined potential will be simply add, that will be U1 plus U2. That will combine potential energy, that will be U1 plus U2, that is combined potential energy. So here we just put the value, that is Q1 V1 plus Q2 VB plus 1 by 4 pi epsilon naught Q1 by R. Now we will solve this, that is Q1 VA plus Q2 VB plus this Q2 will multiply with Q1 Q2 upon 4 pi epsilon naught R. So this will be the combined potential energy in an external electric field because of two system of charges. Okay, just note it down or take a screenshot, and then after we will see the potential in external field because of dipole. Okay, we will derive the potential energy of dipole in an external electric field. We know the dipole, when two opposite charges are placed with some distance, suppose this is the dipole, that is minus Q, that is plus Q charge, and the distance between the charges is 12, and it is placed in electric field. This is the direction of electric field, external electric field is applied here. Okay, now the force will applied in this point, that is in this direction, and in minus Q, force will applied in opposite direction. So if we will see the net force, what we will get? We will get 0, which means here no displacement is being happened. Why? Because net force has become 0. So some movement is happening here, but the position is not going to change. The position is remaining, but it is moving in a rotating manner. So what we will get here? We will get the term, that is tau, which we have already derived in our previous chapter. So we know the tau is dipole moment cross electric field, and the direction of dipole moment is minus Q2 plus Q. That is the direction. Okay. Now just simply remove the cross, then we will get PE sin theta. We can write it like this, PE sin theta. Now to know the work done here, we simply find the small work done. Suppose this is the theta angle, that will be defining the direction of dipole and direction of electric field. Now here a small work done because of this, that will be del W we are marking. It is against the field, that is tau into tau d theta. because if we are taking a small work then the changing in angle is also small, that is d theta. Okay. Now to know the whole work done, to finding the whole work done, what we will simply do, we simply integrate this term. We simply integrate it. That will be from theta 1, initial angle theta 1 to theta 2, tau d theta. Now we will put the value of tau, that is Pe sin theta. Pe sin theta d theta, and it goes to theta 1 to theta 2. Now Pe will come out because it will act as a constant, and we will get theta 1, limit is theta 1 to theta 2 sin theta d theta, and the integration of sin theta is minus cos theta. So simply Pe, the minus will come out, that will be cos theta, and from theta 1 theta 2, now we will put the limits, that is minus Pe cos theta 2 minus cos theta 1. Now here initially we are taking angle theta 1 is 90 degree and theta 2 is theta. Okay. Why initial angle we are taking 90 degree? Because the work done which is applied, that is opposite to the electric field, and to bringing the charge minus q plus q, that are same magnitude but direction is opposite. So that's why we are taking theta 1 90 degree. Okay. So here we will just simply apply it. That will be W minus Pe cos theta 2 is theta, that is cos theta minus cos 90, and the value of cos 90 is 0. So what we will get, minus Pe cos theta, that is the work done in the form of potential energy, which is stored in the form of potential energy. So here we can write it, if we will change in a dot product, we can simply write it minus P dot E, minus P dot E. Okay, this is the work done. Now we will see the work done, potential energy because of the point charges. Here also 2 points we have, and in our previous derivation we have derived the potential energy for 2 point systems in any external field. So here we will apply that because of plus q. Now net potential energy will be because of plus q, that is plus q, and here we are taking VR1. The position we are taking, that is R1, that is q VR1. Because of this point, the energy, potential energy will be minus, because we have minus q, and here we are taking position vector R2, so it will be VR2. Okay, now because of 2 points previously we have already derived, there will be the both point will impact to each other and there will be some potential energy, so that will be minus, this minus q will multiply with this plus q, and minus plus minus, minus q into q, that will be q square upon 4 pi epsilon naught, and the distance between the points is 2l. Simply we will put here like this. Now we will put the value, we just take a q outside the bracket and we will write it VR1 minus VR2 minus q square upon 4 pi epsilon naught 2l. Is that clear? You are clear with this? Now in the place of VR1 minus VR2, what we can put? We can put E 2l cos theta. 2l cos theta is the distance, or you can say displacement against this field, electric field. So we can combine, write it E 2l cos theta. So what we will do, we simply put here value. Just take a screenshot and then I will rub it. I will rub this diagram. Take a screenshot. Okay, now I'm rubbing it. So this VR with VR2 is against the electric field. So we will take it minus E2L cos theta and simply we will put here. So the electric potential energy will be Q into this term is minus E2L cos theta minus Q square upon 4 pi epsilon naught 2L, and this will be minus E 2QL. 2QL is the expression for PE cos theta minus Q square upon 4 pi epsilon naught 2L, and we can write it in the form of product, dot product, that is P into minus P into E minus Q square upon 4 pi epsilon naught 2L. This is the expression for the potential energy due to potential energy of the dipole in an external electric field. I hope this is clear to you.